off or onto silent. Given we had a karakia for the opening of the workshop, that won't need one for this meeting. Apologies. We had an apology for Lara. There were no other apologies. I can have a mover and seconder to accept that apology. Stephen, seconded by Spencer. I'll put that. All those in favour? Against? Carried. There is no public forum. There are no late items. There's no confidential business to be transferred into the open, and there's no change proposed to the order of business. So that takes us to the item 7, which is the minutes of our 11 October meeting 2023. So I'm happy to move receipt of those. Do I have a seconder? Thanks, Stephen. Are there any matters requiring correction or clarification in those minutes? There are not. Been moved and seconded. I'll put that. All those in favour? Against? Carried. Are there any declarations of conflicts of interest in terms of matters on today's agenda? There are not. Okay. We will move to item 9. That is the 9.1 appointment of chairperson of the Wastewater Management Review Committee, and there is a report there commencing on page 23 from Coral, our Manager of Democracy and Governance Services. That's recommending to the council that Spencer is appointed as chairperson of this committee, and acknowledging and thanking Lara for her services to date. I'm happy to move those 3 recommendations. Have a second by Fitty. Is there any discussion, or are there any questions in respect of the report and the recommendations? If there are not, it's been moved and seconded. I'll put that. All those in favour? Against? Carried. Congratulations, Spencer. So in terms of the formal process, it'll come to the commissioners at a council meeting next week as a matter of just confirming that, and then once that's done, officially be chair. Okay, so next item is 9.2 wastewater activities report. Radley, and that commences on page 26.
Thank you. I'll try and scoot through this fairly quickly, but I'll obviously take questions as and when. No problem. So yeah, so just an update on the activities that have been happening. So we've got wastewater consents. Our monitoring has been going through. Results haven't shown any issues, and we've called in consent limits. And Heather, can I change that, or do you have to? Okay. Yeah. So yeah. We have a couple of interesting things coming up within the consents that we're required to do, and one of those is a BINTEC survey out by the outfall. So that's looking at impacts of the discharge on the surrounding environment. We have to do that every 10 years as part of our consent. So the last one was done in 2014, and that's due we're looking to get that underway early next year. There's a certain level of good weather that's required for contractors to get out there and take samples, etc. So we're looking to do that towards the end of the summer when we've got some settled weather. And that report will come back to this committee as well. The second one is a 5-yearly report that we're required to undertake. It's got a fancy acronym MUTA report. It's essentially monitoring and upgrading technology review report. So it encompasses pretty much anything and everything to do with the wastewater scheme and the consents that we have, and how the council have been managing their scheme through the intervening 5-year period. So it's timely that some of the things we'll be talking about later around biosolids and certainly with the PVC and where that's going. Everything seems to be coming together at the same time. We're bringing these sort of discussions to the committee, which is good news. So next committee meeting, we're going to have Becca come and present to the committee. So as part of this 5-yearly review, we need an independent specialist in wastewater schemes to be, I guess, the technical lead for the assessment. And that's previously been done by Becca. And so we're going to get them to come and have a chat to the committee about how they go about that, what they're looking for, and what's sort of included. And that enables the committee to ask any questions they might have and talk about any sort of, I guess, things of interest that they may want that report to have a look at. And that's one of the functions of the committee as well, is to have input into that appointment of the independent assessor and what the report will look at. So we'll do that in February at the next meeting. I added those 2 reports in case you need some bedtime reading, but it was really just an indication of the sort of things that those reports are involved in. So pond 1 desludging, so that's still continuing. That's been going on since October 2022. The contractor has now taken that figure since the report is probably up closer to 8,000 dry tonnes now. They're working on 24 hours a day, so rapidly increasing those figures. We've been monitoring the seepage rates from the pond at an increased level throughout the entire project. And you can see there at the bottom, if I just explain in case people haven't seen one of these graphs before. So this goes way back to our first desludging program. So the first peak that you can see there on the left hand side is way back in, I think, 2016. Our consent requires us to monitor on a quarterly basis. So you'll see that the peaks get closer together. Second desludging that we did back in 2019, where we decided to start monitoring on a more regular basis. And then as the desludging finished, we went back to our quarterly, and then you can see where the peaks get closer together again at the end on the right. So that's where we've been monitoring since this particular program started. So we've been monitoring extra to make sure that as the project moves around the pond, that we don't see any impact from the project on that seepage rate. And you can see that we've had a pretty stable seepage from the pond since the project started, with a couple of peaks where we've had an increased level of water in the pond. And the advice is that that's what's sort of the major impact on the seepages, rather than if the desludging is happening in a particular part of the pond, like the front or anything like that. So we've been seeing good results there. So we've obviously got a number of projects going on at Tamonga at the moment. Bioreactor 2 is underway. That's a pretty recent photo. So we're still working on some remediation of the piling that's required before we sort of get it out of the ground, as you like. And at this stage, it's expected that remediation will be finished sort of towards the end of the first quarter of 24, and the above ground works will take approximately 15 months after we've completed that. So still a little way away from having a second bioreactor commissioned. Clarify number 3 is progressing really well. As you can see from that project, from that photo, we've got sheet piles in, dewatering systems going well, and we're looking at getting pile installation underway. So, we also have a new inlet works that we're looking at, and the first portion of that project will be removing that biofilter, that bio-odour filter that you can see there, the rectangle, and replacing it with a much smaller footprint chemical scrubber, which does exactly the same job, but it's enables us to then start looking at starting the inlet works and concept options and sort of initial works underway. We're hoping we'll have design starting towards the end of next year. So we're still a little way away from that as well. Over the last 12 months or so, we've been doing a sort of condition assessment of the marine outfall. I think we've brought you photos of rovers heading down pipes, and obviously those that were at the Water NZ conference would have heard a bit more about that from the presentation given, and so yeah, so that's sort of done, but we also need to do a dye test which will show us whether we've got any particular issues with the outfall in terms of cracking or seeping. So that needs very favourable conditions. That's not something we can do with any sort of swell or bad weather. So again, that's probably going to be February that we'll try and do that. So yeah, we're sort of waiting for good weather. Bioreactor 3, at the moment we're just doing preliminary site assessments and some geotech and groundwater investigations will sort of get underway next year. So we've sort of talked about PVC, and that's after our discussion earlier. The project team will come back to the review committee in February to sort of discuss those outstanding matters and move on to the next stage, which is long list options. That's Deborah. Got through that fairly quickly.
Thanks, Bradley. Open up for questions, comments. Yes.
Kia ora. Thank you, Bradley. The best, thank you for your report and referring to page 49 around the contaminants. And I just wanted to look at there's levels of arsenic, and could you explain the inorganic component of that, and maybe the source or the type of activities that contribute to that? I think it's nothing to, well, it could be something to do with the actual structures and the management of that, or is it a particular discharge that we're seeing in the into the system that we're not really doing much about until it gets to this stage?
So this is in the benthic report from 2014. Just for those who might not have seen it. Yeah, so there's a level of inorganic arsenic in soils all over the place, I guess. What we want to see is whether there's a trend of increasing that could be related back to the discharge, and so that's what the likes of what we'll be looking at. So we did a very an original one back with the consent application. So the idea is that we do the same measurements each time to get that trend, I guess. So that'll be something that we can ask Bopper to make sure that they comment on.
Kind of looking at, are those the result of activities of the plant there itself, or are they inputs into the treated, like, do we have something from an old milk or something all going into the air that we don't know of? Yeah.
So I do believe we measure for arsenic in the discharge, which hasn't shown any. So we have an arsenic level within the discharge conditions that we have to monitor for, and we haven't seen any increase in that discharge. So it's unlikely to be as a result of the discharge, what we've seen from our regular monitoring of the discharge.
Yeah.
But I guess as part of the benthic study, they'll be also looking to see whether that's had an increase over time.
Would it look at like the plant area itself is looking, looking to kind of expand, and there's the use of that old tip,
yep,
to might break thresholds and start in the next 10 years to affect mahinga kai, which is a key aspect of the MACA, which is part of leading into the other question, how we manage and use that resource. But we might not get the resource in a state that it becomes manageable because it's got too many high levels that we should be able to try and identify where these things are coming from, and yeah, from that perspective.
Sure. So it's, I would say it's unlikely that the Tamunga site itself is impacting on the level of arsenic, for example, in the discharge, just because of the way the system works. However, we do also monitor groundwater from the likes of the landfill as part of those consents that the landfill has, and also around the two ponds and the wetland. So we do have monitoring that we do as part of those consents, which includes the likes of arsenic and the other heavy metals. And those results will be in the 5-yearly report. So as we go through that process, we'll have a review of all that data that we've got from the last 5 years.
I touched on it before, the existing consent resource consenting and the occupation of space in figure 9, page 133. I know this might have been taken in a 2014 context, but is there a 2024 context with MACA available or underway? Or is some of this, we talked about the utility treating relationships, called it, or being built around the engagement for this. It might even align too with the review of some of the legislation like Te Maro, Te Wai, or that. Is that foreseeable for it's going to impact a lot, I would say, on the activities and the expectations of what might come out of the MACA planning process. Marine and coastal.
Yeah, so this report is from the 2019 youth report. So obviously none of the MACA hearings had occurred at that point, so that's probably why it's not even mentioned, although I do believe it's mentioned as coming up in the cultural report that was done. Yeah. So I guess if you'll find more of that will be in, I'm assuming, both the technical report and the cultural report for the new one. There'll be a wider discussion around what's come out of MACA. I guess we're still waiting for some of the judgments around stage 2 and the Waihitapu for Rangatawa Bay.
Yes.
But yes, and I guess as the PBC looks at the future and potential consenting pathways, then obviously the likes of the Marine Coastal Act judgment will have to be taken into account as to how that pathway might roll out.
And just one last one, not in relation to any particular report, was just the reporting with the council structure of wastewater management review. We've also had some stormwater reports, and I would like to ask: is there the opportunity for reporting, like the likes of the generic stormwater consent, to this committee? Is that been considered? Because I know it's up for review, and there are some other elements in there.
I wonder there's though that's getting beyond the terms of this committee. That's all.
Yeah, often asked that because we've had stormwater reports received here, and I was just thinking, is that an opportunity to also present some of the reporting back to this committee? You know, we're dealing with wastewater, but sometimes we get presented the stormwater corridor, and yeah, I think that would be really helpful to link the two together in a water services context as well.
Maybe we are just about to set up more engagement on stormwater. So actually setting up groups with Tanga Whenua to talk about stormwater aspects. And so all the review of the catchment management plans will be part of that as well. So it's a step. So a management plan, catchment management plans we are talking about. And so we're just setting up all of these groups. So next year that you should get invites for that aspect.
With the reporting, would it come back to this forum as well, or is it going to be to under council's engagement policies?
So clearly stormwater is not part of the terms of reference for this group. And so we are looking at how we can report that. So there are reports going up to council on stormwater aspects on a more or less regular basis. And we are talking to Te Wangapu on a regular basis about stormwater issues as well, which includes a freshwater management tool where we have got Kepa Morgan as a representative on the peer review panel as well. So there's a lot of work going on. A lot of interaction is actually happening. But we just don't have the same group as we have for wastewater in regard to stormwater.
Oh, thank you. I would just like to see that report being presented to this committee.
Yeah.
In future, not now.
And the reason I raised in terms of, we have a terms of reference, I think we need to be careful as a committee that that those are the terms of reference, and if we are requesting other reporting, there may be other ways of actually achieving that without adding further to this committee's role. So that's why I'm just testing on that, Des,
Right.
and there may well be some other mechanisms to achieve that.
Yeah, I was just going to say that, yeah, I think it would be good to explore how we can present that to those that want to know that information. And I completely understand that the interrelationship that you're talking about, so I can see value in that. But whether the review committee is the right process for that, we can have a chat about.
Shane. Sorry, just to add my 5 cents worth, it might be beneficial, maybe the other way. So for this committee, you know, we've got agendas and probably got the same people presenting to be able to report back, particularly to Tangata Whenua that are engaged through working on the catchment management plans and stormwater processes for that to be connected across that way.
Just, why I brought it up is that, I like the transparency that through this and receiving reports efficiently. And, council kind of pick and choose who they need to deal with, and I haven't been, some reason, been invited on the, on some of those consultation forums. I don't know why. It's, in the reports that I've received, through my associates that sit on there, is that, it's to policy. And I think that's, I was asking for transparency, and I really believe receiving the reports like that in committee is beneficial to be able to progress these matters forward. That eventually could end up that way through a consenting process. Yeah. That's all. It's looking for some transparency in how we can receive that through the process. Kia ora.
Yeah, so we'll leave it to staff to look at that, because some other mechanisms may assist in that. Okay, any other questions before we move on, presumably to a presentation on biosolids? Okay, you want to introduce that? Then we can move through that. Thanks, Radley.
Okay, so I'll work through this. Gary McDonald from Becker is also going to help present this.
Sit up the table.
We'll do a bit of a tag team here. I'll sort of try and set the scene a little bit, and then Gary, with his much better ability to talk, we'll try not to make it too technical, but a little bit on technologies, and then I might look at the end. So in 2016, some of you may remember we had a biosolid strategy that was created through the review committee. The instigator was a condition in one of our ODA consents around the decommissioning of the sludge pond at Tamanga. And so there was a number of stages that were put through to try and resolve some of those issues that were raised. One was around decommissioning the pond as a sludge pond. That was sort of the first stage, followed by a sort of an investigation into the longer term, I guess, options around biosolids and their end use and what happens to them. One of the things about wastewater treatment plants is that it's something that they just keep producing. So and stage 3 was around what the future of pond 1 may look like, and that's sort of filtered into the conditions of some of the Sweden consents that we have at Tamanga, which talk about that. And at the time, we had this little graph that sort of showed those 3 stages. And stage 1 was around decommissioning the pond, as I said, and we council ended up. Can I get you to move on to the next slide, please? Yeah. So in 2019, council commissioned the thickening and dewatering plant down at Tamanga, and that allowed council to stop disposing of the waste activated sludge from the plant into pond 1. And from then on, we were, as the name says, thickening and dewatering the sludge, and then disposing of it off-site, initially to Hampton Downs landfill, and then over the last, I want to say, 3 or 4 years, an increasing portion of the solids have been going to vermi composting. So stage 2 at the time, we talked about how we were going to thicken and dewater the sludge, and then what sort of treatment options were available. So we had a whole list there of things like incineration, stabilisation, composting, vermi composting, solar drying, thermal dryers, anaerobic digesters. Everything sort of was on the table, I guess. But it's not just around what you do with biosolids. It's then once you've done all that, what do you do with it? So, you know, what we also, we're looking to look at sort of end use options. So whether we use it for energy generation, building materials, application to land, rehabilitation of land. A number of options there. Thanks. So as I said, we've slowly moved, I guess, away from landfill, which not only is it a poor use of biosolids in terms of the resource, but it's also, you know, probably one of the more costly ways of disposing of it. And as legislation comes in around increasing waste levies, etc., and that option only becomes more expensive. Got the transport, which has its own sort of carbon footprint. All these things come into, I guess, making that option less attractive. And so currently, council has contracts in place for 90% plus of our vermin composting to go, of our biosolids to go for composting. There, it's the biosolids are mixed with some sort of carbon. So, for example, in Kauro, it's the paper mill that supplies that portion. That's mixed, goes through the worm treatment, and then is again mixed with more natural compost before it's then supplied to a variety of different land applications, for example, here at fruit farms. Sorry, let me just go back slightly. Yeah, so that's really working well for council and also for the contractors at the moment. But there are always legislative changes that could hinder that sort of end product use. So council's trying to identify other potential alternatives. One that we've had in the last LTP and also is in the draft LTP that's going out for submission is around solar drying. That requires quite a large footprint, but what it does do is obviously reduce the amount of water that's in the biosolids and can make transport easier, cheaper. So it doesn't have an end use as such. You're still trying to find an end use for it, but it does reduce the cost of whatever you end up doing with it.
Last question as we go.
Yeah.
I just wanted to ask about the solar drying. Where would that occur?
It's a good question. At this stage, it could potentially be at Tamana. It does, as I say, it does require a decent amount of land, and obviously you're trying to do that as close to where you're producing the biosolids, so that you're not having to pay those transport costs initially before you then do whatever you do with it. And yeah, okay.
Sorry, just in terms of the solar drying, how long does that process take? And then how much can you kind of manage through that process? Yeah, kind of on an annual basis.
One of the reasons it was put into the long-term plan is that it was something that you're able to stage over a period of time in terms of the amount that you would put through that process. So, you know, a bit like Lego blocks, you could build over time if you need to, depending on it's scalable. Yeah, thank you. That's the word I was looking for. Do you want to?
We've got to demonstrate an example of that later on.
Billy.
What would the owner effects of that solar drying be? You know, close community there. Again, I'm thinking we might be a bit smelly there. If you answer that.
Yeah, it's a good question. So we visited a solar drying facility, and there's no doubt it does have a odour, just like in most wastewater treatment plants, but that's not to say it can't be managed and mitigated with a variety of processes. So Yeah, so what might the future look like? Say we've got the boom composting in place at the moment. As I said before, disposal of landfill is a bit of a wasted resource, and there are a variety of both existing and new technologies out there. And this is not just a Tauranga issue or a New Zealand issue. It's a worldwide issue that communities need to figure out what they're going to do with their biosolids. So, and one of the things that I guess is pertinent to keep in mind is that what's the end use? It's all very well looking at new technologies and all and modifying the biosolids to a certain extent for a particular end use, but if you don't have a market as such for that end use, then it will become a bit academic. So it's around trying to look at both what the technologies are, but also what you might end up doing with the product in the end. So just as a couple of examples there, you might be aware that Auckland are currently remediating, for want of a better word, with the Tutu Island, where there is a quarry, and for the next some say 20 years, some say 30 years, that they'll be putting their biosolids there. I just put in brackets there that essentially it's 1/3 of New Zealand's entire biosolids production that they're doing that with at the moment. And if you think about what happens after that, and Auckland are looking for an end product to the thing, it's maybe something that the likes of Tauranga, if we can get to that stage before they're looking at it, then and have established markets and that kind of thing, then it's probably all the better for us. But and so someone who's done that is New Plymouth, and they have a product called BioBoost that they sell. Taranaki made fertilizer. And, there's a number of examples of that sort of product, especially in the States, producing. It's been sold in retail.
That's a thermal dryer, so I can talk a bit about that. So it's dried to about 94% solid. So there's only a very small. It's a dry product, and you wouldn't know the difference between it and a chemically based fertilizer if you went to the supermarket or Bunnings. Been going for 22 years.
So I guess what we were sort of discussing around the Muta report and PVC, and what we're currently doing with our biosolids, it's sort of this opportunity came up to join Becca and staff from Watercare on a trip to the Water Environment Federation's technical conference, and also a tour of a number of treatment plant facilities in North America. It was quite an amazing. I know some of you have been to the Water NZ conference, which has about 1,200 delegates this year. So yeah, quite a difference in scale, and that's sort of reflected, I guess, also in the sort of type of conference papers and discussions that were had at the conference. A lot of new technologies and practices that potentially haven't quite made it over here yet. And just the complexity, I guess, of what some of those treatment plants are dealing with compared to us in terms of their scale and the technologies being used. So so we'll go through some of the things that we saw, and their reasons for biosolids are quite similar, I guess, in some respects to what we have, but they also have some others. Legislation that they have over there. There are a number of states where they're actually required to try and find an alternative use for biosolids other than landfill. The costs of disposal, I guess, in relative terms are probably the same per capita, but they also have they're looking for reuse opportunities. There's parts of the country that are in severe drought a lot of the time, and so don't have the same options that we might over here in terms of what they do, and also just the volume of biosolids is what we're dealing with is it's quite small in comparison. So it's good to see how they overcome some of those challenges and what we might be able to, I guess, avoid by taking note of what they're doing. In general, most of the biosolids are produced as what they call Class B. So the difference between a Class A and a Class B biosolids is essentially the level of pathogen kill that you get. So, for example, Class A has to be at either a certain temperature or pressure for a period of time to essentially nullify those pathogens. Yeah.
So the idea was to go from the end use, if you like, look at the number of end uses and decide on the technology afterwards, because as you saw on the previous slide, there's any range of technologies, but it's the end uses is where you have either the problem or the solution. And what we were hoping to find is someone is actually getting revenue from the biosolids actually as opposed to being a cost. So many of the plants we went to are called water resource recovery facilities. So they've renamed it. It's no longer wastewater. It's like water resource recovery. It's all in the name. But the branding is quite important. And I'll come to that shortly. Yeah. So there's quite a lot of technology improvements going on. Biosolids have been ignored for quite some time. They're becoming more important because as you increase the level of treatment of the liquid stream, you actually generate more biosolids. The two go hand in hand, unfortunately. The better the treatment, the more biosolids. So you've sort of got this compounding issue. And you've got to watch out for the carbon footprint on the way through with the emissions. So we looked at digestion, is of course happening at Chapel Street, and there are several ways we thought, well, how can you increase the amount of gas that you generate at Chapel Street? So we didn't talk much about Chapel Street, but it's already got digesters, had for them about 30 years. There's several different technologies were listed in here, won't go into them, but this is a pilot plant, believe it or not, that we saw at in Vancouver. At the Lulu Island plant, and they are piloting these, and they're more than welcome. They said, look, come and have a look. Let us know. We're very open with what we're doing. So that's the sort of introduction we're trying to get for Tauranga, to get ahead of the game, if you like, by forming these partnerships with these organisations that are actually doing some pretty clever stuff, as you can see there. Bradley will talk a little bit about renewable natural gas. That's a wee way down the line, but as we decarbonise our natural gas in the pipelines, which are petroleum-based or hydrocarbons, and go into a more biofuel-based economy, there's a possibility that we take the gas from Chapel Street, or for that matter from Tauranga, turn it into biogas through the digestion process, several of which are listed there, and then clean up that gas and pump it back into the network we use it ourselves. We're already using the gas at Chapel Street to generate electricity, but if we can bring more fuel to the digesters or make it more efficient, we can actually produce more gas. So that was one aspect we looked at, was the Chapel Street plant and enhancing the ability to generate more gas there. Next slide, please. Some of the emerging technologies, these were the exciting ones. I've got a couple of samples here that managed to slip through customs. I never said that. Ready for it. No, I did. And look, this is what's called biochar. It's one smell. It's effectively carbon. It's a carbonized form of biosolid. So it's starts out as sludge at around about 20% solids, 80% water. It's dried in these rotary dryers, then dried to a certain stage, then taken up to 1,000 degrees, which kills all the bugs, and also produces a syngas on the way through. So that syngas becomes the fuel. So this is pretty much energy neutral. As you pass this around, this biochar product is virtually pure carbon, but it also still contains the phosphorus and some of the good parts of the biosolids, which normal biochar, which is made out of wood, doesn't contain. So it can be used for agriculture. It can be used as carbon black. Next slide, please. Or it can actually be incorporated into. Oh, where's the concrete? Oh, it can be later. Okay. So it's all right. So we've got some uses, but carbon black is traditionally made out of petroleum. And so there is an opportunity to actually sell carbon black at quite a good rate of return to displace carbon black. And so these are examples of little notebooks where the covers have been dyed with organic biosolids. So it's quite exciting for me. You can tell by I'm quite excited about the fact that we've taken a waste product and turned it into something with value. Now that's the turnaround we want to try and get. And if we can get Tauranga into that space of actually being the leaders in this, then as Radley says, we can get ahead of Watercare with its 350 tonnes a day of biosolids. So we had a talk with the previous slide. We had a talk with the producer of this particular material, and they are shipping some of the material out to test as a concrete additive. Another technology, interestingly enough, take your common microwave at home, scale it up about 2,000-fold, and add a little bit of bleach or hydrogen peroxide. You actually get a very powerful oxidizing agent, which not only through the microwave process heats up the sludge to the point where it kills the pathogens, but also reduces a lot of the mass, the organic mass in the biosolids to make it more amenable to biogas. So this is University of British Columbia. This is a pilot plant. That's probably the second biggest microwave you can get in America at the moment. But it's just using, once again, relatively small footprint, very scalable because once again, Chad, it's modular. So you can only get microwaves up to a particular size apparently, but you just have more of them. So we're looking for those processes whereby you could do one, produce a product. Once the product takes off, then keep adding the scale. So rather than investing in a big thing all at once, like a thermal dry like New Plymouth, we can scale it. Next slide, please. This is the clever, the branding. Americans pretty good at that, as you know. This is called Our Carbon. And so this is the product that's in that little bottle, which is, if it gets wet, it doesn't smell because it's actually pure carbon. Can be used in agriculture, can be used, as I said, ground up and used as carbon black. Or the most promising one for New Zealand is to lock it into concrete. And you're then sequestering the carbon. So you've taken the organic material, which going to a landfill would produce emissions. You're actually taking it through a process that's energy neutral and producing a product that you can then sequester into concrete. Now in America, that becomes, you can get a carbon credit for that. And we are not quite at that stage yet in New Zealand, but trying to avoid carbon cost to the city by actually getting a credit through selling this is one mechanism. So there's quite a strong economic discussion to go on about how you actually maximize the value of the biosolids rather than the costs. So minimizing cost versus maximizing volume is a little equation we're starting to think about. Thanks. The other one that we looked at was the use in horticulture or agriculture. We do have a bit of a problem in New Zealand that we only probably dispose or put to land maybe 20% of our biosolids in total. So we looked at three locations, or these are two of them actually, where you either take the biosolids, you don't necessarily dry it to the extent of the biocarbon, the biochar, but you do take it down to a dry solids, maybe 30% solids, 60% or maybe higher. You then can spread it onto pasture, then crop the pasture for haylage, etc. You can or lucerne. Or you can grow poplar trees. That's what that grove on the left-hand side is, and that's something like 450 acres. 450 acres of poplar trees, which are grown by the utility and then sold for ornamental woodwork, like on the wall here, either plywood or woodwork. Now we're going to start thinking about, well, what wood could we grow that will suck up the nutrients, suck up the water, but also be of value. But it does need land. So that's the question of just how much land could someone like the council own and then harvest a crop that then has a value in itself. So this is all, you can see the husbandry that's gone into the trees, lovely straight trees. And on the right-hand side, this is even bigger. This was something like 40,000 hectares of forest in British Columbia, where that machine there, a modified log hauler, has been modified to spray sludge into the trees. And so it jets sludge into the trees. And that's a joint operation between the water utility and the forestry company. They get the benefit of faster growing trees, and the water company has the benefit of somewhere to put their sludge at virtually no cost.
Just a question about the land-based kind of disposal around the sludge. So, you know, we hear a little bit about what Rotorua did, and but in this case, this is kind of further treatment, further refinement for that product then to be spread onto into forestry, which is a little bit different to what we've got currently. Well, when Rotorua is.
Well, Rotorua was the liquid was going into the forest. Rabbit Island and Nelson uses a similar system to the one in the bottom right-hand corner. And if anyone's interested, I think it would be worth going to see, because that is one location where you can actually see they've been putting sludge into the Rabbit Island forest for quite a few years. And so that's that sort of benefit that we're looking for, is a dual benefit between a forestry company or an iwi group who might own a big block of land and want to actually generate some income from that better than what they're doing at the moment. So I think that's what we were looking at, is these examples where we can take people and show them it's been done here. Here are the problems they had. How can we not repeat those problems? So that was the essence of going to as many places as we could to see what they were doing. But those are two really good examples of one being biochar with the solids you can sell to a different market, and this one owning the land off which you're generating a revenue to offset the costs of processing.
That's a question. Has council looked at some of its lands? Well, we've got a lot of land that's known as the water catchment. It's public, I'd say that, because it was public works acquisition. That has been forested with this, I think, 2 rotations. And I've done some work up there recently with the harvesting. Has it gone any further than like a local desktop? Or are you anticipating on going into, because what you're talking about, I can mention a few other examples, but now that you've brought that up too, it's quite clear that could.
I think, could I suggest that it'd be a really good suggestion to come forward for the Muta report to cover, is just these sorts of, just to float the idea, so the committee could say, that sounds like a good idea, but there's nothing underway at the moment. But I think you were going to talk about just how we might take that forward as well.
Yeah, no, that's always.
No, I was going to say the same thing. So nothing's been looked at in that respect, but yeah, it was something that would fall under something like the Muta. So for sure, we'll talk.
So these are some of the end users, which I've just talked about, but we think there's a possibility in New Zealand, as long as we get over what I call the fecal aversion issue and start thinking creatively about why are we calling this wastewater, when in actual fact a lot of other people are generating really good use and value from the biosolids. And I know that in Selwyn they've got a forest which they spread their effluent in, Chad. There are a couple of ones in New Zealand, but a lot of people don't know about them. It's better, I think it's good to go to the States and learn from what they've done right, but also what they've done wrong, so we don't repeat the mistakes. I know that the climate's different over there and species are different, but you know, we have a large opportunity with our looking at biofuels and biocrops to actually start looking a little bit beyond where we are at the moment and weaning ourselves of chemically based fertilizers and onto biologically based fertilizer. Next slide, please. Oh, sorry, can you go back? I was just going to share. That's the biosolid, the glass house for the solid line, and they have their own. I think it is a 400-acre farm, which they take they load up a shed full of these dried biosolids, which not too different to that sample I sent around, but they're biosolids, and they distribute through a mechanism like this thing on the bottom. Around a farm off which they then grow crops for winter feed, and so winter feed in one instance and corn in another, I think. So they own their own land, but so that's the secret, is either you have a very tame landowner or you own your own land. That's because there's always that worry about, well, if someone sells the farm underneath, where are we going? So that's one of the risks, the commercial risks you have to manage through this land application, because you want to keep doing it. All these people monitor the nutrients in the soil and the nutrients, but if you take the nutrients out in the crop, then you're actually it's not being concentrated in the soil. Okay.
So I was just going to add to that so that the solids in that solar dryer, they go from around the sort of 18 to 20% dry solids to close to 70 by the time they take them out. And that takes, we can take anywhere from a few, you know, a week or so, depending on the summer, to it could be a month in the winter. So this was it, I think. Yeah, and they have quite a distinct seasonal variation in the temperatures. So that's what they were looking at in terms of the amount of time that they were in the dryers for.
And the only thing, sorry, the only thing is that's driving that is natural ventilation, and so you're using, it's evaporating into that saturated air, then evacuate the whole hall of the saturated air, bring in a new lot of dry air, saturate it, and send it back out again. So you can see the circulation fans in the roof, and there is a bit of a smell. It's a bit of a musty smell at the other end. It's a bit like when you open up a compost heap, that slightly musty smell. So it's not a shitty smell, if I can use that expression. I'm an open meeting. It's not a nasty smell, if you like. It's more of that musty, composting, earthy smell.
The biosolids just sits there, and that vehicle on the right you can see is an automated robot that just drives around in a random pattern, turning the biosolids over the time it's in there. So you essentially put a layer on. Doesn't even have to be completely level. The robot will do that as well. Shut the doors and let it go. Yeah, so I was just going to come back here. So what some of the things that, well, biosolids was ever present on the sort of, I guess, discussion table at WEFTEC. Some of the things that were coming up around not just biosolids, so the liquid stream, but was around contaminants of emerging concern. So there was quite a distinction between, I would say, between the east and the west coast in terms of maybe what their priorities were. The west coast were looking at how they could utilise the resource, and we're very involved in finding avenues for land applications and other ways of doing things. The east coast had probably had some more regulatory driven reasons for what they were doing, and so some of that was around quality, and emerging contaminants was something that was quite high on the list. So things like PFAS and microplastics that we've probably all heard of, but and how, so for example, one of the technologies that we saw, the pyrolysis that creates the biochar, gets to such a temperature that actually eliminates those within the biosolid biochar. Decarbonisation was a big topic, and how, and I guess that feeds into a slide that's coming up around renewable energy and increasing biogas for use on plants and that kind of thing, climate change, and also that regulations that I was talking about. So it wasn't just biosolids that we saw when we were over there. All these plants have got a liquid waste stream as well as their biosolid stream. So here, we just get to the next slide. Thank you. Yeah, a number of cities, especially in the California area, have what they call the purple pipe network, and that's an ability to use that recycled water. So they would obviously, the plants have different processes to get to that stage where they have an effluent to use, but a large number of them have some sort of tertiary treatment that enables them to then go and use that water and recycle it. So whether that be filtration or disinfection. So yeah, Brentwood, they use their wastewater on all their sort of ferns, plants, trees, playgrounds, sports fields, and they even enable the community to come and fill up their own tanks with recycled water. I imagine it's quite a lengthy signing process to gain access. There'll be some limitations about what you can use for it, and we didn't actually get to talk to anyone who was using it, but you essentially sign up to be able to gain access, and you get a card and you can fill it up like with your
car, I guess. We understand it was free, but their card was not just sort of your credit card. It was more, I think it was probably something to do with liability, that they knew where the water was going and that you took so many cubic meters or so many gallons of water at such and such a time. So they had that sort of the product chain, if you like. So, but even the mechanism of what they've set up is something we could easily copy if we wanted to. So rather than going for, as Kiwis tend to, is sort of start from scratch, we want to start from well up the developed tree, with risks sort of identified. But that was quite an eye opener. There were 3 of these stations. We didn't see anyone filling up, and we didn't fill up.
But you know, it was quite interesting, given that I think, you know, Jim brought a paper with the Space came to the last meeting around potential for using, you know, some of our recyclable water. So, but it was also used in areas where, you said, I remember they had a nice wildlife park, wetland quite close to the plant, and so a portion of their effluent was directed to that area to keep it a wetland, I guess, throughout the year, even when their conditions were, you know, dry. So, and as Gary alluded to, they're also using it, not just their biosolids on crops, especially in California where there's the obvious drought restrictions. Fields and fields of cotton and almonds.
Just pointing out that, so that I only use the cotton and almonds. I don't know whether they grow in New Zealand, but it's interesting in a dry place in California where there's lots of indigenous rights or claims over water, and there's lots of claims from everybody over water, which is scarce. Almonds and cotton both have high water uptake, but also high value. So it's sort of driving them to use treated effluent. Otherwise, the farmers got no livelihood. So once you start looking at, well, what's the needs and what's the value, that's the sort of thing. And Queensland, just across the Tasman, Brisbane, Queensland is growing a lot of cotton, and I didn't even know it until I went and saw it being grown over there. So as you keep your eyes open to what people are doing, you start to think what would be relevant back in the Bay of Plenty or New Zealand.
Just want to make a comment as well. I mean, we, from a construction point of view, you know, we have a lot of road codes everywhere. So from a dust suppression, so rather than using potable water as, you know, yeah, so, you know, there's opportunities there, I think.
Yeah, absolutely. I know. Yeah, well, it's something that certainly I think we will look at as part of you know, the process that we're going through around trialing using some of that water. The next step, or an obvious next step, would be something like dust suppression, where we you know, no one wants to be using you know, treated drinking water to suppress dust. So,
just on the quality of the recycled water, is that similar to what we are producing at Kamani?
No, there's a Californian standard, which I think is Title 22, which you have to treat to. So it's a relatively high standard. It's not like desalination or anything, but you do have to take the next stage of beyond what we do at Tamanga. The pathogens are one thing, but also things like colour and odour. So there is a standard we have to treat to. But you could take a portion of the effluent and give it a go if you like. And on the master plan for Tamanga, we have identified, haven't we, an area where we might put an advanced treatment plant in. Once again, very modular, probably go through membranes. Maybe even use some of the old membranes from some of the old people.
yeah, so we do treat to a reasonable standard, especially at Tamanga with the UV plant. But it's just that final final clean polishing almost of the water that would be required, and something like a membrane plant would do that. Yeah. And that's a lot of the plants that we saw had something like that as a sort of tertiary filtration.
Yeah, Bill, I can't. I sort of say it's more if you were to reach that standard. I think if you had something that was drip irrigation or buried irrigation, you wouldn't have to go to such a high standard side. It all depends on the use. So I should have made that clear. I sort of, if you're referring to that, then a particular standard you have to go to. But if you found a use that didn't have a lot of public contact or any possibility of public contact or human contact or animal contact, then you could probably almost use the effluent you got now. It all depends on the end use.
So the other thing we briefly mentioned before was around biogas, and at the moment Chapel Street produces approximately 50% of the power it needs through that cogen unit. Hopefully you can see the numbers that this, I think this was Eugene that was producing this. So on the top right there, they had a number of ways they were getting power. They obviously could draw it from the grid. They had a large bank of solar panels out the front, which it was quite an interesting. They actually managed to convince someone to pay them or pay to put them in for them, and then they got them for I think about 20 years or something. So it was essentially free power for them, but it was just a sort of top up, because as you can see at the bottom, they were producing so much gas from the plant that they were able to generate well over 100% of their energy that they required, and were actually feeding that back to the grid.
They were also bringing in what's known as co-digestion. I mentioned earlier on. They're bringing in high strength industrial waste that would otherwise be going to a landfill. So they were bringing in, I won't say sort of cans and cans of old Coca-Cola, but that's sort of really high strength waste. It's like an octane booster, and that enabled the digestion with the existing volume to produce more gas, which gave them more power. So they were doing the best for their community by saying, "Well, bring your high strength waste to us," and they cleaned that up, put it in the cleaners said they screened it to make sure it was okay to go into the digesters. So that's a possible step. And several other plants in the States are doing just that. It's called co-digestion, where you bring in high strength waste to supplement the waste, the human wastewater.
One of the plants we went to wasn't industrial waste that we were looking to use, but it was like a food slurry from their waste, organic waste collections. So that's another thing. But again, that similar co-digestion increased the level of biogas. And so, yeah, one option was that you'd use that on the plant to heat your water that you needed to heat your digesters, for example. But the other thing that a lot of the couple of the plants we went to was that they actually began selling their gas back to the gas companies. We've already talked about the maturity of their carbon credit system over there. Gas companies are looking at how they can, sort of as greenwashing a little bit, I guess, that how they going from your petroleum-based natural gas to a more renewable product. And so these gas companies were quite keen to receive this gas. And so instead of using any of the gas, they had a process that would feed it into the gas network, and then they would just take back what they needed and do the sort of pluses and minuses at the end of the day for the gas companies. So they were selling their gas to the gas companies, and the carbon credits for that sat with the seller. So they were then able to resell those credits on the credit market for a profit as well. So they sort of got twofold. One thing they did say, they were starting to get a bit of competition from some of the very large dairy farms they had over there, because their gas because it was a worse pollutant than biosolids, was actually had more credits. So some of the really large dairy farms were starting to compete. But yeah, it was a really interesting, and those two pictures down the bottom there are a couple of gas. So essentially, the gas goes in, and then they have to purify the gas because it's got a lot of carbon dioxide and trace gases in it. So it's just a process they go through to clean it up for the gas companies.
carbon dioxide and a few others, and leaves it with pure methane. So that's, but a very mature industry. I mean, you can bring one of those into the country easy. It's we don't have to worry about developing technology. There's about 3 different ways of doing it. We saw all 3. So once again, lots of learnings.
Yeah, I think that's nice. Yeah. And this, I put this photo in because I always thought the Chapel Street had a great view. That's McLaughlin wastewater treatment plant on Vancouver Island. And just to the right of that picture was a cruise ship as well. So it was a spectacular view for a plant that was completely enclosed, nothing open to the air. It was all essentially buried.
Up until about 5 years ago, that's the city of Victoria on Vancouver Island. They were discharging screened raw wastewater to the harbour through a long outfall. The government then imposed a secondary treatment standard on them. They looked around and said, well, this is where all our waste arrives at. So they put a completely enclosed treatment plant on this spectacular point of land, which used to be an old fuel depot. So it's interesting how quickly things can happen if a regulation comes into play.
The old BMX track. Yeah, and sulfur, you know, with the now the marine precinct.
Any further questions, Bradley?
Great presentation, lots of exciting ideas. Looking forward to hearing the ones that are commercial and self-funding.
Yeah, I think it's a as I say, the timing's really good with the discussions that I hope we will have as we go through the unit report and PVC and yeah, there's some really interesting stuff out there and a lot of opportunities.
Bradley, you mentioned, I think at the beginning of the presentation about provision in the draft 24 LTP. What's the nature of that? Just as a matter of interest.
I probably should clarify that I guess with the current format, it's not in the LTP because the LTP only takes account of the first 2 years of water budgets. Yeah. So it's been pushed out into subsequent years. One of those reasons is because we have those contracts in place for vermi composting, but it's so we've been able to push that out as well.
I think, Reddy, we got some money in for it to do some study work or investigations. That's one.
Yeah, so there's some planning budget that we've kept in there, obviously, because we want to be looking at what's available. And
Well, there's nothing.
Are you aware of the current application for biosolids re-injection? Oh, are you aware of the current application for biosolids re-injection? Councillor labouring should have been notified.
sorry.
The biosolid re-injection at the Green Park disposal site.
So
Oropi.
so someone's disposing of biosolids up there.
Application, consent application. So I thought council would have known about that being the neighbour owning the quarry, water catchment lands. Oropi.
Yeah, no, I wasn't aware of that, whether it's private septic tank disposal maybe, but yeah.
At the moment, it's our only option for our septic tank disposals.
Yeah.
Same area, but it's just up here. I thought council would have been part of the regional would have notified, but it's notification would have triggered to neighbours as well as Tangawhina have been involved in the
potentially if it's
consultation.
so it's Western Bay
area.
Yeah, so
Tauranga City Council owned land. Right next door.
Well, their new ship is joining landowners.
Yeah.
is it water supply catchment?
Yeah.
Yeah, okay. So the water team, the water supply team may be aware of it as a notification, but I haven't been asked to comment on it yet.
It was taken for water catchment, but never used for water catchment. This is the top of the Waimapu. Not the Waiorohi, which is the current Orohi, or the Toto, which is further across, which is the Joyce Road.
I said specifically designated. What was interesting, we didn't cover several of the plants in the States are actually regional plants where they have several different wastewater treatment plants all contributing to a centralized biosolids facility. So that's, you've just flagged something that could well happen under a new entity, people talking to each other and saying having a regional solution rather than just a single solution.
Yeah, it's part of the regional biosolids strategy. I thought it would be. Anyway.
I was going to leave it, but I won't. And it's in relation to the MUDA report, National Salt Biosolids design strategy thinking, whatever it is. It does strike me. I see there's a note there that there'll be a cultural report. One of the general concerns I have is that there's this main report, study, investigation, and the Māori issues get put off into this other thing. And it does strike me that into the future, if we are to address everything properly, it should all be in one thing. It should be consolidated, should be dealt with at the same time. So I don't know what that looks like, but that's certainly just the point I wanted to leave on the table and to give that some more thought.
Yeah, thank you for that, Spencer. Certainly you're right, the last report, they were almost sort of separate reports and were then integrated at the end. Yeah, absolutely happy to have a discussion about how we might integrate them better.
Sorry, I was one of the authors of that last week. That was the direction from the committee at the time, and that was the second iteration. So moving through to this third review stage. So yeah, it would be good to kind of see that integration through.
He's a 2020 Conroy Donovan.
Okay, no, thanks, Gary. Thanks, Radley. Fascinating presentation. And I never knew, certainly in terms of what the opportunities are in terms of the use of biosolids. So you've certainly for me personally increased that in terms of my radar, in terms of what the potential is. So thanks very much for that. And I now need someone to move and second receipt of the activities report. A mover and seconder for that. Thanks, Fiddy. Seconded by Stephen. There's nothing further. I'll put that. All those in favour? Against? Carried. So that brings us to the end of the meetings. So thanks very much. And as I said, I've just said, never know what pops out in terms of what's happening in the wastewater space. Fitting. Oh, we're going to close, eh?
Kia ora tātou, kia tātou kua koetahi nei, kia ka whanaia, kia hoa mahi, tēnā koutou, tēnā tātou katoa. Nō reira, me whakakapi, kia me tātou. E te atua anei, mātou e koetahi nei tēnei ahi, ka tuku rā ngā whakawhawhiti nā whakawhetai kia koe, mai mā tanga katoa, nei mana ki tiara tātou, a te rātou, ka koetahi anō, ka te whiriwhiri anō ngā tātou, we nei a koe tanga, ko te tumanako, kia whai koe, kia whai ora he tina mā tātou katoa. Ni te atua tēnei mā tēnei kia koe, kore ki tō mata.
Thanks, Shad. The meeting is closed. Thank you.